3.2, day 3, how well the line fits the data, S and R squared. So we're just going to get a measurement of how well our line fits inside the data points, essentially, just like the title says. So first we're going to look at the standard deviation of the residuals. So the first blank there, to assess how well the line fits all the data, we need to consider the residuals for each observation, not just one. So we're going to look at all the residuals. And then using these residuals, we can estimate the typical prediction error. And notice I have typical in quotes here. The typical prediction error when using our LSRL, or the least squares regression line. So for the standard deviation of the residuals, what we're looking at, standard deviation of the residuals, it's actually this big formula right here. Don't worry about writing it down or memorizing it. We use a variable lowercase s, so that's our variable. It's lowercase. So s is a variable, particularly for scatter plots and linear regression. It represents standard deviation of the residuals. And that gives us the approximate size of a typical prediction error, or a typical residual, basically. So how far away you are from the line, what your error is from the line on average. So one thing I want to note is S will have the same units as the response variable, or the Y variable. So in our celebrity guessing activity, you could say the best guesser probably on average had the smallest residuals, so they were the closest to the line. So they would have the smallest value for S. The standard deviation of their residuals will be the smallest. Maybe that makes them the best guesser. Okay, so if you look at this formula again, I won't make you memorize it or actually do this by hand, but this actually looks really similar to standard deviation from chapter 1. The only difference is this one's divided by n minus 2, and when they calculate this difference up here, they take each y value and subtract the prediction. I mean, that's just how you get a residual, actual minus predicted. So in general, what is the standard deviation of the residuals? That's S. So that gives the typical size of a prediction error, or just that's basically a residual. And the reason I had typical in quotes before is because we weren't dividing by n. So it's not like a true average. Otherwise I would have said the average prediction error. It's not a true average, but it's kind of like an average. So I just say typical and I put it in quotes because instead of dividing by n, you divide by n minus 2. Okay, so let's get back to where we were here. How do you calculate these? Well, you could do it by hand with the formula, but you can also do it in your calculator. So anytime you do linear regression, it saves this list called the resid list. So if you use your calculator to calculate S, you do linreg, and it stores this list of residuals. So we can actually take the standard deviation of that list. So if you hit second stat, that's the list function, and go to math, there's an option in there for standard deviation. So if you call that up, standard deviation, and then you just have to tell it what you want to take the standard deviation of. So if you've already done linreg, just go tell it to take the standard deviation of the resid list. So that's second stat resid. That's how you call that list up. And then it will actually give you the standard deviation of the residuals for that data. And then the most important part for this is how do you interpret it? That's the biggest component for the AP exam, is being able to interpret these things. Like they'll give you most of the time the values. You don't even have to calculate it, but you do have to make sense of it and interpret it in the context of the situation. So for the interpretation, and I use kind of a cookie cutter approach for S. So note my quote, using the LSRL, which one? The LSRL that predicts the Y values, whatever those are, using whatever the X values are. So you replace those with actual context from the scenario, the Y variable and the X variable. So using which LSRL? This one. We can expect, or we will typically be off by about, in whatever S is, whatever that standard deviation value is, that many units in our predictions. And again, S has the same units as the response variable, or the Y variable. So this right here is your golden ticket to being able to interpret the standard deviation of the residuals. Using the LSRL, and this is the context part, the one that predicts the Y using X, will typically be off by about S units in our predictions. Okay, so now let's just actually do one of the examples here. For the can tapping example, the standard deviation of the residuals is S equals 5.00 milliliters. Interpret this value. So basically, if you remember the can tapping example, two students shook up a bunch of soda cans, and then they were trying to see if they tapped on them for a longer time, they wouldn't explode as much, like there'd be more soda left in the can. So let's use that same approach I just outlined. So when we use our LSRL, and this is from a previous example, which LSRL? The one that predicts the amount of soda remaining, that was the Y variable, based on the X variable, which was the tapping time. When we use that LSRL, our predictions will typically be off by about 5 milliliters. So again, I just use that cookie cutter approach. I hit all the necessary components, and I would get full credit for interpreting S, the standard deviation of the residuals, in this scenario.